Hello everyone, my name is Saurabh Borkar and my topic of presentation is X-ray diffraction and Bragg law. So firstly we discuss about what is X-ray diffraction. So X-ray diffraction is when X-ray beam is incident on any crystal, it diffracted. As we shown in a figure, there is a X-ray beam which is diffracted, and each dot on photography plate represents a position of an atom. So basically X-ray diffraction is a phenomenon in which the atom crystal, by virtue their uniform spacing, causing an interference pattern of wave present in an incidence beam of X-ray. The atomic planes of a crystals acts and on X-ray in exactly same manner as does uniformly ruled diffraction grating on a beam of light. In next slide, there is a X-ray which is incidence on atom with an angle of incidence theta, and there is a constructive interference that is n lambda equal to 2d sine of theta. So nextly we discuss about invention of X-ray. Uh, so Lawrence Bragg and Sir Henry Bragg, which basically introduce a Bragg law. So we firstly discuss about Sir Lawrence Bragg in 1915. Sir William Lawrence Bragg was an Australian-British physicist and X-ray crystallographer. Discovers of Bragg law of X-ray diffraction, which basic for a determination of crystal structure. So, with the help of Bragg law, we can easily find out a crystal structure of any atom. Next is Sir William Henry Bragg. That is a Sir William Henry Bragg was an English physicist, chemist, mathematician, and active sportsman who uniquely shared Nobel Prize with his son Lawrence Bragg. In 1915, they got a Nobel Prize for their service in analysis of crystal structure by means of X-rays. So nextly we discuss about some graphs. There is a graphs between a angle of incidence and intensity of a X-ray. So as we shown in a graph, there is a uh, angle of theta, that is angle of incidence, which is increasing, then the intensity of X-ray is decreasing. Um, uh, there is a variation in a temperature. There is a um, effect of temperature on the intensity of any X-rays. There is a in 1,000 degrees centigrade, as you see in a graph, there is 1,000 degrees centigrade. There the intensity of X-ray is very high, and then in 600 degrees centigrade the intensity of graph is very low. So this is a first X-ray diffraction view of Martian soil. So the graphic shows result of a first analysis of Martian soil by the chemistry and mineralogy experiment on NASA Curiosity rovers. The image reveals the presence of crystalline feldspar, pyroxene, and olivines mixed with some amorphous material. The soil samples takes from wind-blown deposit called rock, rockenest. within Gale Carter, where the rover landed, is similar to the volcanic soil in Hawaii. The Curiosity scoped of a soil on October 15, 2012. The 69 solar of a Martian days or Martian days. Uh, it was delivered for X-ray diffraction analysis on October 17th of 20, 2012. The by the directing an X-ray beam at a sample of recording how X-ray are scattered by the sample at an atomic level. The instrument can be definitely identify and qualify minerals on a Mars for a first time. Each minerals has unique pattern or rings, fingerprints reveals its presence. The color in graphic representation in intensity of X-ray with being a most intense. There is a red spot, there is intensity of X-ray is very high, and there is a light blue spots, there is a intensity of X-ray is very low. Next is X-ray crystallography. So, what is X-ray crystallography? X-ray crystallography is a experimental science determine the atomic and molecular structure of crystal, in which the crystalline structure cause a beam of incident X-ray to diffract into a many specific direction. As we shown in a figure, there is a X-ray tube, and there is a X-ray beam incidence on a crystal. So it is scattered on a photography plate in a specific direction. By measuring the angle of angles and intensity of these diffracted beams, a crystallographer can produce three-dimensional picture of a density of electron with the crystal. From this electron density, the mean position of atom in crystal can be determined, as well as their chemical bonds, their crystallography disorders, and various other informations. So this is a X-ray crystallography. This, with the help of this, we can determine a type of bond, crystallographic disorders, and various information. So nextly we discuss about a Bragg law. So there is a beam of X-ray. It's a incidence with an angle of theta. It is reflected off the atom of a crystal with a some angle of theta. The X-ray refracted off atomic planes in a crystal that are a distance of d apart. The X-ray reflecting off two different planes must interference constructively to form interference pattern. Otherwise, the X-ray would interfere uh, destructively and form no pattern. To interference constructively, the difference in path lengths between a beam and a reflecting of a two atomic planes must be whole number n of wavelength lambda or n lambda. This leads to Bragg's law n lambda equal to 2d sine of theta. By observing interference pattern, the internal structure of a crystal can be deduced and see by Bragg's law. So nextly we discuss about some applications of Bragg's law and X-ray diffraction. So we determine the size of atom. As we all know, the in the first slide there is a uh, we can determine the size of atom also with the help of X-ray diffraction. and the length and the different types of chemical bonds also. Next is atomic arrangement of material. We discuss about atomic arrangement, that is tetragonal, and various types of arrangement are there. So we can determine with the help of extra diffraction, the difference between material at atomic level. So we can differentiate various materials and mm, at atomic levels for determining the crystal integrity and grain orientation, grain size, film thickness, and interference roughness of alloys and metals. We can determine the thickness of film and grain size or roughness of any alloys or metals. Used to identify structure of various biological materials, vitamins, uh, pharmaceutical drugs, thin films, materials, and multilayer materials. It has become one of standard ways of analyzing a material if a structure is unknown across a geological, environmental, chemical, material science, and pharmaceutical sectors, due to non-destructive nature and its high accuracy and precision. And X-ray crystallographer includes measuring a thickness of films. Thank you.